Section 4-4 is equations as relations. So some relations can also be represented by equations. For example, if you have y equals 3x minus 1, we can certainly come up with a lot of ordered pairs in table form or xy ordered pair form that would show relationships between the x's and y's and would allow you to either graph or show the function as a relationship. So let's look at some of this. A solution of an equation in two variables is an ordered pair that results in a true statement when you substitute it into the equation. So one of the ways you'll be asked to do this problem is to solve using a replacement set. So for example, if I give you an equation, y equals 2x plus 3, and you're given a solution set. This is just a group of ordered pairs that we're going to see whether they're true or false. So we're going to do -2, -1, -1, 3, 0, 4, and 3, 9. So I'm going to set up a table. I'm going to have an x column, a y column, a column into which I'm going to plug that xy into my equation, and then I'm going to decide whether it's true or false. So the first order pair is -2, -1. So y is -1, x is -2, and I substitute those in, and I get -1 equals -4 plus 3, -1 equals -1. That's true. So that is part of my solution set. Let's try the next one. -1, 3. This time y is 3 and x is -1. So I get 3 equals -2 plus 3. 3 equals 1. This is false. Do the other two on your own and see whether or not those ordered pairs are a solution to this equation. A second way is to solve just given a domain, and domain means the x values. So we're going to try to solve y equals x plus 5 if the domain is the set -3, -1, 0, 2, and 4. Okay, so we're going to set up another table, but this time we only have our domain values. So I'm going to put x here. I'm going to show my equation and find my y value, and then I'm going to show the solution as an xy ordered pair. So if x is -3, and I plug it into my equation, I get y equals 2, which gives me the ordered pair -3, 2. So it's similar to the last one, except that I don't know what the y is to begin with. I'm trying to find the y value. Let's try -1. -1 plus 5 is 4. So my ordered pair is -1, 4. And again, do the last three on your own and see what you get for your ordered pairs. Then we're going to be asked to solve and graph. So again, I'm going to be given an equation, 4x plus 2y equals 10. And I'm going to be given a domain, in this case -1, 0, 2, and 4. And I'm going to have to find my ordered pairs and then graph them also. So I'm going to use the same method. There's my x. My problem is that this equation is not in terms of y. So let's go off to the side and let's solve this. First by subtracting the 4x, 2y equals -4x plus 10, then dividing by 2. So y equals -2x plus 5. And that's what's going to go in here. I'm going to find my y, and I'm going to find my ordered pair. So negative 1 is what I'm going to start with from my domain over here. Negative 2 times negative 1 plus 5 is 7. Negative 1, 7. 0. Negative 2 times 0 plus 5 is 5. So 0, comma, 5. So I've done the first two. Again, you try the last two, and when you're finished, simply plot those points on a nice little graph. The two that I have are negative 1, 2, 3, 4, 5, 6, 7, and 0, 5. And you should get two additional ones to plot. The last thing we're going to look at is solving an original equation for a different variable. So if I give you an equation like distance equals rate times time, and I want to solve for r, that means I want to isolate the r. So to get r by itself, I'm going to divide by t. Divide both sides by t. And that will give me r equals d over t. So that's all you have to do. And that is the end of our video. I told you they'd be short, so you're all set.